Hello again, Algebra 1. This week we are going to be talking about distance, rate, and time problems. So these are problems that come up often on tests like the SAT, PSAT. They are very useful types of problems too. So we're going to just dive in and do some examples and see how it goes. So example 1. Okay, example 1. A plane set off to New York City at a speed of 234 miles an hour. On the return flight of 11 hours, the plane cruised at 294 miles per hour. How many hours long was the flight? Okay, so I'm going to go through and look at a few things. So, the question it's asking me is how many hours long was the flight to New York City? That's the question I need to know. Then it gives me some information that I can use to figure it out. So, it goes to New York at a speed of 234 miles an hour. On the return flight, it takes 11 hours and it goes 294 miles per hour. So I got two things. I'm going to make a little note here. So, to New York, we're going to have speed, time, distance. And then we're going to have from New York. So two things here. So speed to New York looks like it's 234 miles per hour. Speed from New York on the return flight looks like it is 294 miles per hour. Time to New York, I don't know. This is actually what I'm trying to find, because it says how many hours long was the flight to New York. So this is my unknown. This will be my X. Distance, I don't know the distance, but I'm going to have to find the distance. Let's see, from New York, the time was 11 hours. And I don't know the distance. I'm going to need to find the distance because I have to have two of the three things here. So, to be able to find this one right here, the time. So, what I'm going to do is I am going to use what I know about speed, time, and distance. So, I think about what do I know? Miles per hour. That tells me how many miles I go in an hour. I've got hours. So we have a formula here that we're going to use. Anytime you see a problem like this, you're going to use this formula. Speed times time equals distance. Sometimes you'll see this as rate, which means the same thing. Times time equals distance. So I've got my speed. I've got my time, I can find the distance. Because over here on my to New York City, I'm missing 2. I can't find the time if I don't have the distance that it goes. So I'm going to start with going from New York, figure out the distance, then I can plug it in on the to New York side. So speed or rate is 294 miles per hour. Times 11 hours, that is going to tell me how far did I go. So if I go 294 miles every single hour, and I do that for 11 hours, I just need to multiply 294 times 11, and I get 3,234 miles. So this is my distance. So I'm going to use this with my speed to find the final answer. So, to figure out how many hours did it take to get to New York City, because we're going a different speed, we're going to plug our numbers in. So I've got my speed is 234 miles per hour times time that I don't know, so I'm going to leave that as t, or you can use x, is equal to the distance, 3,234 miles. So to solve this problem, I'm going to divide both sides by the thing that's not my variable, keep this variable here. Divide both sides by 234 miles per hour. That gives me 1 on the left side. And 3,234 miles divided by 234 miles per hour tells me that the time that it took, t, is equal to 13.82 hours. So it makes sense they went a little bit slower on this trip. If you notice the number 234, it's about 60 miles an hour slower than 294. So on the first one we know it took 11. On this one it took 13.82. So it makes sense to me that my answer is smaller because, my miles per hour is smaller, so that means the time it took me, because I'm going slower, it takes me a longer time. Okay, let's look at another example. Okay, example 2. Okay, Jenny traveled to Burbank, California by car. Going there took 7 hours, and the return trip took 9 hours. Jenny averaged a speed of 74 miles per hour while returning. So 74 miles per hour goes with returning. Find the average speed of the trip there. So similar to what we did on the first problem, we've got to Burbank, and then from Burbank. Then I'm going to have speed, time, and distance. So you can create this chart basically every time. So rate times time equals distance. So we can call this rate of speed, if that helps you remember that rate. So going there to Burbank, the time was 7 hours. From Burbank, the time was 9 hours, and the speed was 74 miles per hour. Distance is unknown for both of these. And it wants me to find the average speed of the trip to Burbank. So this is what my question is asking me, is for this piece right here. So, similar to the first one we did, we're going to need to find this distance first. So, I know that my speed or rate from Burbank was 74 miles an hour, so 74. And then my time is 9 hours. That will tell me my distance. So just grab a calculator, 74 times 9, and you get 666 miles. That's the distance. And we know that since they're going to Burbank and from Burbank, it has to be the same distance. So now I can use this information, plug it into my formula, that says rate times time equals distance. And I can solve for my rate of speed. So my rate of speed, I don't know. I can call that r or x times 7, because that's the time it took, is equal to 666. So to solve this, I'm going to divide both sides by 7. That gives me a 1. So I've got 1r equals, I'm going to grab a calculator and do 666 divided by 7. And I get 95.14 for my rate. So I know the units on that have to be miles per hour. Ooh, they were going pretty darn fast trying to get there. So they went 95 miles an hour on the way there. Okay, let's do one more example. Example 3. Okay, so this one's going to be a little bit harder. So Sarah left downtown Denver, and 3 hours later, Michelle left going 43 miles an hour faster so she could catch up. So Michelle left going 43 miles an hour faster. After another 2 hours, Michelle finally caught up. Find Sarah's average speed. Okay, so now this one's going to be a little more complicated, but we can still do it. So we've got two people. We've got Sarah, and we've got Michelle. And we can still work this out with our rate of speed, time, and distance. So we're still thinking about rate times time equals distance. So rate of speed. Sarah's, we don't know, and we want to know how fast she's going because it says find Sarah's average speed. So this is the part we don't know. So let's think about it. So Sarah leaves downtown Denver. 3 hours later, Michelle leaves, and then 2 more hours later, she finally gets there. How many hours was Michelle driving? Michelle was driving for just 2 hours because she left, drove for 2 hours, and finally catches up. How long was Sarah driving? So she drives for 3 hours before Michelle leaves and drives for 2 hours. So Sarah's driving for a total of 5 hours. The distance in each of these is the same. We don't know what it is. But we are going to do this with some different algebra skills. So, rate of speed, we do know Michelle's rate of speed. She was going 43 miles per hour faster. So the way I'm going to do this is I'm going to say Sarah's rate of speed is x, and Michelle's rate of speed is x plus 43. So she's going 43 miles an hour faster than Sarah was going. So this is going to be a little bit different. Like I said, we remember that distance is equal to, rate times time is equal to distance. I could say distance is equal to rate times time. So the distance is the same for each of these. I can say for Sarah, she's going x miles an hour times 5 hours, and that's going to be equal to the distance. For Michelle, I can say that she's going x plus 43 miles an hour times 2 hours for some distance. Because these are the same distance, I can take these two equations, take their other sides, and I know they have to be equal to each other. So x times 5 is equal to the same distance that x plus 43 times 2 is equal to. So I'm going to combine these together. I'm going to have 5x, just switched it around to normal standard form, equals, I'm going to switch this around and put 2 first, 2 times x plus 43. This came here. So I know these have to be equal to each other because they end up going the same distance. So let's figure out what x is. So first thing I want to do is distributive property. I'm going to take this 2, multiply it by x, and then multiply it by 43. So 5x is staying the same, nothing happens to it. And then this is 2x plus 86. So next step, I'm going to subtract 2x from both sides. That gives me a 0. 5x minus 2x, 3x equals, so that's 0, plus 86, so 86. To solve, I'm going to divide by 3. That gives me 1. And I get x equals 28.67. So what did x represent? If I scroll back up here, I can find my x. X represents Sarah's rate of speed. And that's what I was being asked to find in my question. So I can say my answer is Sarah's average rate of speed was 28.67 miles per hour. So make sure you're taking notes, and I will have your classwork ready for you soon, and I will see you soon on Zoom.